Hi, Matthew Schoenhardt here of MS Consulting, and today we're going to talk about linear versus non-linear probability and impact scales. So a quick background for you first. A risk is defined as its probability times its impact. And the bigger the probability and the bigger the impact, the bigger the risk. And then what we do is we take those risks once we've determined their probability and impact and we plot them on a grid. And so we can visually see where the most important risks are. And then we use this probability impact and the expected value to measure our risk tolerance. And we color code that grid with red at the top right hand for unacceptable risks, going all the way down to green in the bottom left hand corner for acceptable risks. So let's talk about linear versus non-linear ways of measuring or bucketing each of these probability impact scales. What's nice about linear is everybody understands a linear scale. I understand that when I go from 5 kilometers an hour to 10 kilometers an hour, or 5 miles or 10 miles an hour, I've doubled my speed. It's a nice linear scale, so it's really easy to understand. And these linear scales are super easy to create. You know, you take your probability, if you're going to have a 5-point scale, every 20% increment is a different chunk on that scale. Really easy. Non-linear scales are not easy to understand. I mean, ask somebody to explain how the SPF factor number works, or say the Richter scale works, and you're going to get a lot of confused faces. So non-linear or logarithmic scales are a little bit tricky to understand. They're not intuitive. But the good news is that you basically explain with a logarithmic scale, every step in the scale doubles in magnitude from the step before. That's a little bit easier. And then because you have that non-linear logarithmic scale, you have those buckets. They very well map to verbal anchors like unlikely versus probable. And so that helps quite a bit. Let's look at that for a second on an example. So we're going to take a $100 project. Why? Wow, because it's massive. It's a $100 project, and we're just going to look at cost risks only for the sake of simplicity. So here are our 10 risks, and you can see the probability and impact of each of those risks. And you can basically calculate the expected value. Now, our risk tolerance on this project is going to be measured by expected value. And anything that has an expected value over $3 is an unacceptable risk. And anything that has an expected value under 25 cents is a totally acceptable risk. So let's look at that and take a linear and non-linear scale. So on the left, we have a linear scale that with 20% increments for our probability scale and $4 buckets for our cost impacts. On the non-linear side, we go 5%, 15%, 33%, and you can see we're sort of doubling every time we go up the scale. And then our costs also double on the horizontal scale. When we plot the risk tolerance that we stated before on the left or the linear scale, we can see most of the graph is covered by red. Guess we're going to have a lot of unacceptable risks. Whereas on the non-linear scale, we see that there's a nice yellow band down the middle delimiting our unacceptable risks from our acceptable risks in that gray-yellow area. And so that's kind of nice, visually appealing. So let's take our 10 risks that we came up with and plot them on the scales. What we can see is when we plot all those risks on the linear scale, we see all of those low risk items, those acceptable risks, those yellow in-between risks, they all tend to cluster in that bottom left-hand corner, and they don't give us a lot of differentiation between each of those risks. And that big red area is almost void of all our risks because it's taken up a lot of space, but we only have 4 unacceptable risks. When we look at the non-linear side, we can see that the risks, the same 10 risks, are spread out all over the graph, and we can see distinct clusters, and we can see the difference between, say, risk 7 and risk 4 a lot more easily. And it uses up more of the space. This is a little helpful, I find. So here are my conclusions. I hope you looked at those and maybe you paused and you can rewind and eyeball it yourself, but the non-linear logarithmic scales are much better suited for verbal anchors. When we say that something is probable or very likely, we're actually talking orders of magnitude. And so these logarithmic scales increase our ability to better determine qualitative evaluation of risks, which is one of the first steps in evaluating the risks. And this qualitative approach with encourages the mindset that we're going to try to evaluate risks in terms of orders of magnitude. And that way all the decimal counting debates that you've seen in risk meetings, those drop off because we're talking about, is this a 4 or a 5? Hey, there's an order of magnitude difference between a 4 or a 5. So that's really helpful. The second one that I find most helpful is that it visually separates the risks a lot more. It uses up the page a lot more effectively, and you can clearly see how much different one risk is from another. And so those are my thoughts on linear versus nonlinear scales for measuring risks. My name is Matthew Schoenhart. The website is datadrivenrisk.com. See you next week. Thanks.